Hi, my name is Ifan from Solution Center, bringing mathematics to your doorpost. The only thing you have to do is just click on the subscribe button, stay tuned, and get a secret behind every mathematics approach you need to understand. Today we are going to look at SOLD. What is SOLD? SOLD is simply defined as the root of rational numbers, or they can equally be defined as the rational numbers. What do we mean? Numbers that are not determinable except their approximate values. Example, we have roots, root 2, root 5, and another example, we have root 7. These are what we call SOLD. They are rational numbers. These are rational numbers, and we call them the roots of rational numbers. Why? Because their exact values are not determinable except their approximate values. Now we're going to look at the rules of SOLD. What are the rules of SOLD? The four rules of SOLD. The four rules of SOLD is one. We have the multiplication law. It says root a, SOLD a times SOLD b will be equal to SOLD a times b. What does this simply mean? That two SOLD can multiply each other to give you a product. Then two, we have SOLD a divided by SOLD b, which is equal to SOLD a all over b, which means that two SOLD can divide each other. Then the third law, we have SOLD a plus SOLD b is not equal to SOLD a plus b, which means that two SOLDs that are not similar cannot add each other. Then we go down to the fourth one, the fourth law, which says SOLD a minus SOLD b is not equal to SOLD a minus b, which means that two unsimilar SOLDs cannot subtract each other. Now, because we are dealing with similar, all this why in the third law and the fourth law, let's explain what a similar SOLD is. What is a similar SOLD? Two SOLD are said to be similar if the irrational part, these are the irrational parts, if the irrational parts contain the same numeral, we say that the two SOLDs are similar. Example, if I have A SOLD x and B SOLD x, these two SOLDs are said to be similar. Why? Because the irrational part here contains the same numeral. The irrational part contains x. These are the irrational parts, SOLD x, because the two SOLDs are similar here. Now, let's go down to another example. If I have x SOLD 2 and y SOLD 5. These two SOLD here are not similar. The two SOLDs, SOLD 2 and SOLD 5 are not similar. Therefore, here we say that root 2 is not equal to root 5, which means that the two SOLDs are not similar SOLD. Now, this will lead us to what we call conjugate SOLD. When we say that two SOLDs are conjugate if they multiply, if the product of the two SOLD results to a rational number. That is, when the two SOLDs multiply each other, their result, the product, gives a rational number. We say that the two SOLDs are conjugate to each other. Example, let's go down to this conjugate SOLD. Conjugate SOLD here, we have example, have root a times root a. Root a times a here will give us root a times root a here will give us a. That is, the product of these two SOLD results to a rational number without any root attached to it. Therefore, assuming we have two SOLD in this form, root SOLD a plus SOLD b, we say that the conjugate of this will give you SOLD a minus SOLD b. How do you obtain the conjugate of this particular SOLD? Just changing the sign. Change the sign between the two SOLD. You have the conjugate of each other. Now, if I have another example, SOLD a minus SOLD b, the conjugate of this SOLD still remains SOLD a plus SOLD b. How do I obtain it? Changing the sign between the two SOLD. Now, this now leads us to what we call the simplification of SOLD. Now, before we go down to simplification of SOLD, we have to discuss what we call the basic form of SOLD. When we say that SOLD is in basic form, the basic form of SOLD, when we say that a SOLD is in its basic form of SOLD. A SOLD is found in its basic form when the factor of that particular SOLD is not when none of the factors of that particular SOLD is a perfect square. Example, I have root 7, I have root 5, I have root 11. These SOLD here are in basic form. Why? Because their factors can never give you a perfect square. But if I have this particular example, root 18 is not a basic. Is not a basic form. It's not a basic form of what? A basic form of SOLD. Why? Because it has a factor that's a perfect square. What is the factor that's a perfect square here? It is 9 times 2. 9 here serves as a what? 9 here serves as a perfect square. Therefore, because 9 is a perfect square, we say that root 18 is not a basic form of what? Because 9 here serves as a perfect square. 9 is a perfect square. We say that root 18 is not a basic form of what? SOLD. Now we simplify SOLD. Simplification of SOLD. How do we simplify this? Simplification of sort simply means breaking down sort to its simplest form or expressing sort as a single sort. Now let's go down with this particular example under simplification of sort. Example 1, which says reduce, let's just break down this particular example. Reduce root 50 to its simplest form. Reduce root to its simplest form. Reduce root 50 to its simplest form. Under solution, we are dealing with root 50. How do we reduce it? Root 50 contains a perfect square. What is the perfect square in root 50? Perfect square is root 25. So root 25 times root 2 will still give us root 50. So we have expressed this, breaking it down into two simple sorts. Now, what will give us the perfect square? The square root of 25 here is 5. 5 times root 2. 5 times root 2 will be equal to 5 root 2. So this is the simplest form of this particular sort. Now, what if we have another example here? Reduce, which says reduce. We have reduced the fourth root of 1250. It reduced fourth root of 1250 to its simplest form. Reduce the fourth root of 1250 to its simplest form. How do you get this particular example done under solution? Now what we're going to do is you look for the fourth of 1250. What will it give to you? Number there that can multiply itself 4 good times to give you 1250. That's what we're going to look into. And what will it give to us? From here we break it down. The fourth root of 1250 here will just give us, we have it, fourth root of 1250, which is equal to the fourth root of 625 times 2. That is 625 multiplied by 2 will give you this. So we now break down this particular source, separate it. We have fourth root of 625 times the fourth root of 2. And fourth root of 625 will give us 5. 5 times the fourth root of 2 will still give us 5. Fourth root what? 2. We'll break it down to its simplest form. Now let's go down to this particular one, the single sort. How do we express it as a single sort? Let's go down to example 2. Express 5 root 2. Express 5 root 2 as a single sort. As a single sort. How do you express as a single sort under solution? 5 root 2 as a single sort. What you have to do, just bring down your root, then have this as a root, as a square. That is opposite of root. That is 5 square times the irrational part, which is the 2, is equal to 5 square will give you 25. 25 times 2, we have it as root 50 as a single sort. We don't have any other rational part attached to that particular sort. Now let's go down with this particular question. I would like you to solve this question. Send your answer as a comment or through my email address. I'll receive it. Then in my next class, we're going to do justice to this particular question I'm going to give to you here. Just a simple question. I want you to take down the question. Have example. We have example 1 is assignment. Please, let's go down to this assignment 1, which says express the following as a single sort. Express the following as a single sort. We have a is 5 fourth root of 2. Then b we have 3 and seventh root of sum 2. Now let's just go down with this assignment. Express the following as a single sort. Express this as a single sort. Express this equally as a single sort. Now in my next class we're going to do justice to this. For you to stay tuned, just click on the subscribe button and the bell for more notification. Remember that the answer to this particular question should be said as a comment or via my email address. Thank you and see you some other days. Bye.